Geometry, we're going to finish up this packet 2 on the line and angle relationships. Okay, so previously we've talked about scavus. And I've said we have to have parallel lines cut by a transversal in order to have these relationships. So none of these relationships exist unless we have parallel lines cut by a transversal. Well, I lied to you. 2 of them do exist no matter what. And the 2 that exist no matter what are vertical angles and supplementary angles. So you do not need parallel lines cut by a transversal for vertical angles to be congruent and supplementary angles to sum to 180. The vertical angles are always congruent. You just need an intersection of 2 lines. And supplementary angles, you just need a linear pair. All right. So let's go ahead and work out some vertical angle problems here. You can see that these 2 angles right here are vertical angles, so that means they're congruent, which is why I made the congruency marks on these angles. So to solve for x, I just set them equal to each other because I know this angle is equal to this angle. So x plus 16 is equal to 4x minus 5. All right, I need to get x by itself. I have an x right here and an x right here. It's easier to move this x over here. So I'm going to subtract x on both sides. That cancels out. Now I put the minus x underneath the 4x because they're like terms. I can't put it underneath the negative 5. They're not like terms. I can't combine them. All right, so I bring this 16 down, bring my equal sign down, equal sign. 4x minus x is going to give me 3x. Remember the coefficient when we don't see one is 1. So 4 minus 1 is 3. And then bring down this negative 5. So the only thing we do is cancel out the x and then subtract the 1x from 4x. All right, now I've got x on one side. I need to get it by itself. So I need to get rid of everything around it. Let's get rid of any terms that don't have x in it. So the inverse of subtraction is addition. So I'm going to add 5 to both sides. That will cancel that out. And then 16 plus 5 is going to give me 21. And I'm just going to bring my 3x down. So I have 21 is equal to 3x. I'm going to rewrite this over here where we have more room. All right, so 21 is equal to 3x. All right, my last step is to do the inverse of multiplication because this is 3 times x. So the inverse is division. You're going to divide both sides by 3. So that gives you x is equal to 7. All right, so what if I asked you for the degree measurement here? X is equal to 7, right? So is this 7 degrees? No. I need to plug 7 in for x in both of these situations and see what I get. So over here, 7 plus 16, it's going to give me 23. So this would be 23 degrees. If I plug in x here, I should also get 23 because vertical angles are congruent. So 4 times 7 gives me 28. 28 minus 5 gives me 23. Can I also find what these angles are? Remember, look, these are a linear pair. They're sitting on a line together. They're supplementary, so they have to sum to 180. So I can figure out this measurement by doing 180 minus 23, and that gives me 157. If that's 157, so is this. All right, if I added up all 4 of these angles, they should sum up to 360 degrees because an entire circle is 360 degrees. So let's see if we did that right. I'm going to do 23 plus 157 plus 23 plus 157, and I get 360. So I know all my degree measurements are correct. All right, over here on example 29, this looks kind of crazy because there's an extra line, right? But what I need to do is identify the vertical angles. So let's just see where the lines intersect. So there's one line, and here's the other line. So here are the 2 lines. These are my vertical angles across from each other. So I can just set these 2 expressions equal to each other because I know that vertical angles are congruent. All right, now I use algebra to solve for x. I'm going to subtract 3x on both sides. (5x minus 3x gives me 2x, and I bring my 10 down. My last step is divide both sides by 2, so I'm left with x equals 5. So does that mean this is 5 degrees? No, we need to plug x into this. So I'm going to plug x in here. So that's going to be the same thing as doing 5 times 5, which gives me 25 degrees. If this is 25 degrees, then this should also be 25 degrees, but let's plug in x to make sure that we did it correctly. So I'm going to do 3 times 5, because x is 5, which is 15, plus 10 is 25. All right, now I can solve for the rest of these angles. So looking at this, I know that these two angles right here are a linear pair. They're sitting on this yellow line together, so they have to add up to 180. So this must be 180 minus 25. All right, so 155. All right, so looking at that, I know this whole angle over here is 155 as well, but I've got this extra angle. What does this box mean right here? It tells me that this is a certain type of angle. So this means that this is a 90-degree angle, and I know that overall these two angles together must sum up to 155. So to find this missing piece, oh my gosh, I'm going to do 155 minus 90. That will give me my missing angle right here, which is 65. So when I add these two together, they equal 155 because these two big angles are vertical angles. 65 plus 90 gives me 155. All right. Supplementary angles are linear pairs. They always sum up to 180. So I know that this angle and this angle are equal to 180. I'm going to do x plus 118 is equal to 180, because when I add these two angles together, they equal 180. So to solve for x, I subtract 118 on both sides. So 180 minus 118 gives me 62. So this angle right here is 62 degrees. You could have just done 180 minus 118. All right, example 31. Now I've got two expressions. Well, I know they're linear pairs because they're sitting on a line together, so they have to add up to 180. So I'm going to take this angle and add them together and set them equal to 180. So 2x plus 10 is my first angle, plus x plus 26 is equal to 180. So I just have this angle and this angle. I added them together, and I set them equal to 180. So take a minute and see if you can combine like terms and solve for x. All right, here was my answer, x equals to 48. So I identified my like terms, 2x and x. So when I add them together, I get 3x. My constants are always like terms, so 10 plus 26 gives me 36, and we continue to bring down the equal sign in the 180. To get x by itself, I'm going to subtract 36 on both sides. So I have 3x is equal to 144. The inverse operation of multiplication is division, so you divide both sides by 3. 144 divided by 3 is 48. Now remember, 48 is not the angle measurement. I would need to plug it back into the equation. So wherever there's an x, I'm going to put 48. All right, and I should get different angle measurements this time because they're not congruent. They sum to 180. So 2 times 48 plus 10 gives me 106. 48 plus 26 gives me 74. So when I add these two together, 74 plus 106, I should get 180 because they're supplementary. All right. Example 32. I need to get a separate piece of paper for this. I didn't give us much room. All right. I've got 3 different angles, but overall, these 3 angles are sitting on one line together. So this angle plus this angle plus this angle, all three angles together would add up to 180. So I'm just going to do the same thing I did for the other one, but this time I have three angles that I'm adding together. So the first angle is going to be 6 minus 10. That's my 6x minus 10. Plus my second angle, 4x plus 6, plus my third angle, 7x plus 14. When I add that all together, they add up to 180 because they're supplementary. So I need to go through and combine my like terms. Anything with an x in it is going to be a like term because it's the same variable x raised to the same power, which is 1. So 6 plus 4 is 10. 10 plus 7 is 17. So when I add those together, I get 17x. My constants are also like terms because they're always like terms. Remember, the subtraction sign stays with the 10 and makes it negative. So I'm going to have negative 10 plus 6 plus 14, and I get a positive 10. And then just bring down your equal sign and your 180. So equals 180. All right, so I had combined my like terms to get 17x, and I combined my constants to get 10. And then I just bring down my equal sign and my 180. All right, I'm trying to solve for x, so I need to get rid of everything around x. Let's start with the constant. So I'm going to subtract 10 on both sides. Bring down this 17x. 180 minus 10 is 170. And then you're going to divide both sides by 17. So 170 divided by 17. Oh, I hope you didn't write down my credit card number. 10. X equals 10. All right, remember, all those angles are not 10. I can figure out what these angles are by plugging 10 into each expression. So let me go to Desmos so I can show you. Wherever there, so I'm going to write x equals 10, so I remember. All right, so I'm going to put a parentheses, and I'm going to put 10 minus 10. So you see it's that same expression, I just put 10 in for x, and I get 50. So this is 50 degrees. All right, I'm going to do the same thing here. 4 parentheses 10 plus 6. And I get 46. So I know this must be 46 degrees. And I'm going to do the same thing here. 7 parentheses 10 plus 14. And I get 84. Alright, so I know that all three of these together, if I did my math correctly, should add up to 180. So let's see. 50 plus 46 plus 84 is equal to 180, because they're all just sitting together on this line. Alright. Let's go ahead and summarize these main ideas. Alright, so when parallel lines are cut by a transversal, the following statements are true. So let's go ahead and remember what our SCAVAS is for. What's the first S for? Supplementary. What's the C for? Corresponding. The first A, alternate interior. The V, vertical. The second A, alternate exterior. And the last S, same side interior. All right. So now let's go ahead and write what's true. All right, so I know that my two S's sum to 180. So I'm going to write supplementary angles sum to 180 degrees. And I know that same side interior angles sum to 180. All right, so the S's sum to 180. The kava is congruent. So I'm going to go ahead and write that statement. Corresponding angles are congruent. Alternate interior angles are congruent. Vertical angles are congruent. and alternate exterior angles are congruent. Remember, congruent means equal. All right. So let's go ahead and give some examples of all these different types of angles. So first tell me, what are the two parallel lines? All right, I hope you said lines M and lines L. M and L are parallel. All right, line N is the transversal. All right, so give me an example of corresponding angles looking at this. All right, I'm going to say angles 1 and 8. You could have also said 4 and 7. You could have also said 2 and 5, and you could have said 3 and 6. All right, give me an example of alternate interior angles. All right, I'm going to say 4 and 5 because they're alternate sides of the transversal and on the inside of the parallel lines. You could have also said 8 and 3. All right, what about alternate exterior? All right, I have 7 and 2. You could have also said 1 and 6. All right, same side interior. All right, I have 8 and 4. You could have also said 3 and 5. All right, vertical angles. All right, I said 7 and 5. Remember, they have to, the tip of their vertexes have to be touching. They have to be sharing a vertex. So 7 and 5. You could have said 8 and 6. You could have said 1 and 3. Or you could have said 4 and 2. Now remember, for all of these relationships, you have to have parallel lines cut by a transversal, except for vertical and supplementary angles. So vertical angles are always congruent. Supplementary angles always sum to 180. And remember, they could also be called linear pairs. All right, great work.